I'm Jameel, and you're watching The Variety Show. Today, we'll be talking about chemistry on the streets and acidified redox reactions. Hello! I'm Jameel. How are you?
Fine.
What do you know about acidified redox reactions?
Oh, is that like the Clorox bleach?
America. Jameel, it's coming. Hello, I'm Jameel. Have you heard of me?
No.
Okay. Have you heard of acid redox reactions?
Is this kind of a racist joke? Are you being racist to me now?
This guy here. Oh look, another individual for Jameel. Hello! Have you heard of me? I'm Jameel.
I pick things up and put them down.
That's nice. Have you heard of acid redox reactions?
I pick things up and put them down.
Jameel's looking for another interviewee.
Well, hello.
Wow!
Well, hello. I'm a retired chemist.
Where are you from?
India.
Well, what do you know about acid redox reactions?
Well, it's been many years. But if I remember correctly, acid and base redox involves the transfer of electrons from one thingy to the other.
Well,
And then oxidation is the loss. The loss. You feel the loss
please back. Please back.
of electrons. And reduction is the game. I must fix my home. I must fix my home.
Okay.
And so, you see, we can remember this by saying, Leo says girl.
Wow, that's a new one. Jameel here, with a friend from India.
Hello.
I hear you're old chemist.
Indeed.
Now, I fear for my safety because I've heard of spies.
Spies.
Agents.
Agents.
Acid redox reactions.
Oh, no. Not spies. Agents. Not like 007 agents. Like agents that reduce and oxidize. A reducing agent gets oxidized, and an oxidizing agent gets reduced. That's how you remember them to do the opposite. But every redox reaction has a reducing agent, which reduces the oxidizing agent, which oxidizes the reducing agent.
So, Jameel's safe.
Well, there are many steps to balancing your own acidified redox reactions. Come with me to my laboratory.
Okay. Oh, you left the doo-doo lying around. You need to clean up after yourself.
So this here is our unbalanced equation, step 1. We have an iron 2 ion with a dichromate ion, turns into an iron 3 ion, and then just a chromium 3+ ion. Step 2. Separate the equation into 2 half reactions. So in step 2, we make 2 half reactions. We can keep the 2 ions together and the 2 chromates together, right, to create 2 separate reactions that are occurring.
Step 3. Balance the atoms.
In step 3, we balance out the atoms. You see here we have 1 iron atom combining with 1 iron, or turning into 1 iron atom, so we don't need to balance the atoms. But here we have 2 chromate atoms going to 1 chromate atom, so we have to multiply, so we have to make 2 chromate atoms on this side.
Step 4. Balance the O's and H's with H2O and H+.
So now we have to balance our oxygen atoms. As you can see here, there are no oxygen atoms in this half reaction, so we don't need to worry about it. But on this half we do. We have 7 oxygen atoms in dichromate. So in order to balance this out, we add 7 water molecules on this side to balance out our 7 oxygen molecules. But when we do this, we also add 14 hydrogen atoms. So to balance that out, we add an additional 14 H plus ions to this side.
Step 5. Add electrons to each half reaction to balance out the charges.
For our 5th step, we have to balance out the charges. In the iron half reaction, we have a 2 plus charge on this side and a 3 plus charge on this side. So by adding an electron onto this side, we can balance the charge to 2 plus and then 3 minus 1, which is 2 plus. On this side, we have a 2 minus and a 14 plus, which adds up to 12 plus. And then on this side, we have 2 3 pluses, which adds up to 6 plus, which means this has to be a 6, right? Excellent. So, we're making this 6 electrons here. Then we can show, we can balance our charges, because now this here is 6 minus and 6 plus, and this is 6 plus.
Transition.
Step 6. Multiply the half reactions by a coefficient so that the electrons lost equals the electrons gained.
Step 7. Add the 2 half reactions to get a complete equation. Cancel out the spectators.
Since we don't have any electrons in our final balanced equation, we have to cancel out our electrons. Since we have 6 electrons here on this equation and only 1 on this side, we're going to multiply this half equation by a factor, coefficient of 6, so we can get the electrons to be the same in both reactions. So here you can see now we have 6 iron atoms going to 6 iron atoms with 6 electrons. And then step 7, we'll combine the 2 half reactions to form the final reaction. As you can see, we would add the 6 electrons from the left side, the right side, to the 6 electrons on the left side. And so they cancel out, and we end up with this final equation here. Thank you, Steve.
Hello, this is Jameel. Thank you for watching The Variety with Jameel. I'd like to see you next week. However, I'm traveling to Malaysia and to Japan and Australia. I can't wait to see these jumping kangaroos. Alright, it'll be 2 weeks. Thank you. Jameel is gone.